So combining 3D machine vision and edge devices with AI. So we looked into what machine vision is, what the edge computing means, and then we now going to talk about how this can be combined together. And just to clarify even more further, when we think about machine vision, it's nothing but it's just the ability for a computer to see. It employs more than a variety of different cameras can be applied, and it's a simplification of analog to digital conversion. And how does that work? There are cameras which are capturing visual information in the form of videos, images, and it can process those images or videos real time on the edge devices. And this technology is often used in environment such as where you need to make real time decisions because the processing and analysis can happen real time. And let's look at how we have evolved over the last, hundreds of, in terms of the human evolution and drawing a correlation with the machine vision and the perception side. So as a human brain, you have a touch, speech, vision, facial recognition, and coordination. And that's how our brain operates this fast. And the machine vision side, that's what we are trying to replicate, but only the vision part. The coordination, touch, and the speech doesn't happen. The vision part and the perception part happens here. And that itself is a very powerful intelligence because now you have a lot of data to work with, from that. And in the computing power now. So when we think about kind of the perception and the understanding and the coordination, which is correlation is the machine vision there, which is the camera system. The computing power, the correlation is our brain. But this is where it multiplies exponentially the computing side. Over the years, or more than 300,000 years, the human brain, how it has evolved, and the smartphone chips is less than over 12 years. And if you think about the active users, we have about 7.5 billion human users and 6.5 like in the smartphone chip. But I want to draw the correlation of how the neurons, we have about 100 billion neurons, and in the smartphone chip, just in your pocket, it has 10 billion transistors. And multiply by, as the decades to come in the future, this computing power will continue to get faster and get more and more there. So doing the computation at the edge will evolve significantly as we look into the future, and we will see massive advancements in this, applications now. So where the edge systems are moving now. So the center of gravity, when we think about the edge, mining enterprises are the perfect fit. On-device intelligence is paramount. As we can see, you can process the data closest to the source, your physical sensors, and it can complement to the clouds, which means we don't have to move the data to the cloud all the time, but you can move the relevant information. And it benefits the latency issues, reliability, and privacy concerns that always emerges to move the data in the cloud goes away. And it can also support remote operations. And we can also not overload the network bandwidth that is required in moving this heavy data, which is a lot of video data, a lot of 3D imagery data here. So applying this to mind to mill, so which is the camera systems, which is the 3D studio systems and the edge computing. And we can gather a lot of useful information that can be utilized for mind-to-mill operations and different stages here. What this system is, what we call here is the Netra system. And this is a 3D studio vision system, which has wide-angle 3D AI sensors built in. It has the ability to capture the depth information, which means how the entire physical structure measurement happens. It can capture that. And it can take 100 photos per second, which means at each frame. It can work indoor and outdoor, very resistant to different rugged mining environments here. And it also comes with built-in IMU and the other type of sensor to stabilize and calibrate the actual hardware here. And when it combines with the edge device, which is a very high-powered GPU computing systems, so your data is processing real time, which can complement these advanced camera sensors with the computing devices here. How we can apply this into the day-to-day mill production or the plant side, either at the trucks, where the gantry, where we can install and detect the oversizes, at the loaders, at the crushers for real-time fragmentation to understand our throughput, as well as the belt to understand and continuously measure run-of-the-mill operation. So what it allows you to do is really understand and establish a benchmark for your size that's coming out from your blasting, which helps understand what's my throughput is. Either your goal is to reduce the crusher gap. This gives the data now. Understanding of the mine-to-mill energy consumption now, and which leads to a reduction in carbon emission. But more importantly, where I see the biggest benefits are, now you know the data, you can do a real-time adjustment to your plant settings now. And we have already seen use case about the foreign object detection. So how the setup works. So you have the camera systems, and then the camera is connected to the edge computing through a physical connector, which is powered by your regular power. And then the edge devices are also connected to a network. This could be various options, either just the LTE, Wi-Fi, or the hardwire. In this case, where we are transferring the data to the cloud after the results are analyzed. So AI-generated results are synchronized to the cloud. Cloud services gives you an ability to now really monitor your plant data from anywhere. So how the AI works at the edge devices, these are small devices, but very, very powerful, which means it's taking the data, as you can see the raw data. It has AI model built into this edge systems, which has multiple variable models are there. So you can see, you can do a lot of detection, segmentation, 3D analysis from this model, tracking of each particles that's been flowing through, contamination of the objects, and all those triggers can be built to understand where it is and what's the adjustment is needed. So these objects are all available in that models, which are being trained to understand and analyze and perceive this information. And this can be utilized in the dashboards to see what are the implications that we are seeing in our plant now. So this gives a little bit more understanding. As you see the video being played now, what it shows, it's a depth estimation video, which means it is looking at different parts and understanding and building a true 3D understanding of different particles that's been flown here. You're not seeing the actual 3D rocks here, but you're seeing the depth, which gives you good measurements. And that's what is the power of the machine vision AI. And these GPU systems are being able to real-time process this information, even though it's a heavy data, you can see being processed in real time now.